So next topic is very important, as I told you just now. Numericals, not numericals, they ask you this question. Okay, so let me write the questions first. See, the question is this. They'll ask you, actually my topic, okay, today's topic, starting topic is this one, huh? See, let me write the topic heading, then I will tell you the questions, huh? See, so our topic heading is PN junction diode. This is our heading, actually, this is our topic. So what question they can ask you, let me tell you now. See, the first question they will ask you is, okay, what is a PN junction diode? That's the first question. Okay, number one. Don't worry, you will get it, you'll understand as we proceed. Then they will ask you, okay, what is depletion layer? Okay, that is what they ask you all the time. What is depletion layer? You can check the question paper also. Okay, number three, they'll also ask you what is depletion layer. Then they'll ask you what is potential barrier. Okay, potential barrier. These things together also they can ask you, but expect around 3 marks. Okay, if they ask you 3 marks, or at least let's say 2 marks. And check now, okay, how to answer these things. I am going to talk one after the other. Okay, but at least you know right now what is p-type semiconductor and what is n-type semiconductor. Okay, so let's see now what is this. Okay, see, I told you how does p-type semiconductor looks like, how does n-type looks like. I'm going to take n-type semiconductor. You can see where I have lots of electrons. Same diagram I'm drawing. Majority charges are electrons on n side. This is n-type semiconductor. It's a solid, okay, and I have some holes also here, right? Minority charges. Then I'm also going to take your p-type. Look at this, the p-type semiconductor. What am I doing? Just check. Am I keeping them far or am I joining them, guys? Just check the diagram.
Joining them. Okay, I really join them. Okay, and this is what, this is called as junction, right? Junction. Okay, this is the layer, right, or the region where the two materials, n-type material and p-type material, have been joined together. That's region where they are really joined. Okay, that is known as junction, actually. Okay, and this whole device, okay, this whole is this everything right now, okay, it's going to act like a device, which is very important. Okay, very important, as I will show you. Okay, very important property it has. Okay, and this device is known as p-n junction diode. Actually we call it diode. Simply also we can just call it diode. Okay, so if I ask you what is a diode, can you tell me what's a diode? Simply, diode is an arrangement of what and what, guys?
p-n junction.
No. Arrangement of n-type semiconductor joined with a p-type semiconductor. Okay, and when we join, we get a region exactly in between, right? That's like a boundary. Okay, and that boundary is known as junction. Okay, so don't forget. Okay, now these two will act like a single piece. They were two separate pieces. Now they will behave like a single piece, and check their properties. So nice. Okay, just check. See, tell me whether you understand or not now. Okay, see. Okay, first of all, let me ask you, do you agree these electrons that I have drawn, okay, they are electrons, or I have drawn them free electrons, guys? They are free electrons. They are electrons in the conduction band. And here also, these are also electrons in the conduction band. Okay, what are these holes, guys? They are free or not free? What do you think? Holes can move or not?
They can move.
Yes, they can move. Even holes can move, even electrons can move. Okay, now see. So the first thing that I should tell you is this. Okay, this is going to happen. See, if I look at the n side, okay, if I look at the n side, this one, if I look at the n side, tell me, okay, which charges are majority in the n side? Majority. Negative charges, the electrons. Okay, fine. Which charges are minority? Positive charge, or let's say holes. Okay, on the p side, again, majority are who? Holes, and the minority are electrons. Okay, now see, okay, I do not know whether you have learned this or not. Okay, can I say that there is concentration difference on both sides or not? Concentration difference.
Yes, sir.
Okay, there's a concentration difference on both sides, on either side. Okay, if I look at the left hand side, I see lot of negative charges, but if I see on the right hand side, the p-type material, okay, I see a lot of positive charges. Okay, this is called concentration difference. Okay, I can just show you another example, and then I think it will be clear. Okay, see, if I have a closed room, okay, and then
there's a small opening here, okay, and this is oxygen here, lots of oxygen in the other side of this room, okay, and there's lots of carbon dioxide in the other inside the room. Can you understand? Lot of carbon dioxide inside the room, lot of oxygen outside the room, okay. So you tell me, inside the room whose concentration is more? Obviously
Carbon dioxide.
carbon dioxide, okay, and outside the room whose concentration is more?
Oxygen.
Oxygen. Automatically, if there's a window here, okay, from where gases can move, right, what will happen? What will you find, guys? Oxygen will start entering where?
The room.
Inside the room, okay. It will go from a higher concentration, okay. Oxygen will go from where? Higher concentration region to a region of same concentration or lower concentration,
Lower concentration.
because inside the room there is lower concentration of oxygen, okay. So oxygen will try to go inside the room from higher concentration to lower concentration, okay. Similarly, carbon dioxide also, what do you think, guys? Inside the room it has higher concentration, outside the room carbon dioxide has lower concentrations or density, okay, not density, concentration, okay. What will happen to carbon dioxide? Carbon dioxide will automatically go where, guys? Outside the room. Can you understand? This process has a name. Have you learned this called diffusion, guys? Have you heard about this one? In gases it happens, okay. Whenever gases are free to move, no, gases will always try to go from higher concentration to a region of lower concentration, and this process is called what, guys? This process is called
Diffusion.
diffusion. Is it okay for all of you guys?
Yes, sir.
Okay, the same thing is going to happen here. See, guys, so now you think and tell me, tell me, whose concentration is large on the n side?
Negative.
Negative charges. So negative charges, they will do this. Look here, they will start moving, okay. They'll move, they're jumping across, okay. They are overcoming, not overcoming, let's say they are crossing the junction. That's the word let me use, okay. So negative charges will cross the junction, okay. I should have drawn here plus 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 plus, okay, and they will go from higher concentration region to lower concentration region, okay. I think this part is clear till now, okay.
Yes, sir.
Same process, okay. What do you think will happen with the positive charges, guys? These positive charges, they'll sit there or they'll go to the other side? They also will move to the other side, okay. They will go towards the n side, they will start diffusing, okay. The positive charges also, they will start diffusing, okay. Now let me tell you more in detail. See, don't think that this far electron will come and cross the junction. No. What do you think, guys? All the electrons will cross the junction or only the nearby electrons? The electrons which are the electrons which are near the junction, they are going to cross. Don't expect all the electrons. So let's say this electrons will cross, this electron will cross, this electron will cross, this electron will cross, okay. We have huge population, by the way, okay. So I'm just drawing that, okay. See now, okay, so diffusion will take place and it will look like this, see, guys. And even the holes, okay, don't expect all the holes to cross, but the holes which are close to the junction, they have reached where now? Check. The holes which were on the p side, they have reached where, guys? N side. And the electrons which were on the n side near the junction, they have reached where, guys? They have reached
Side.
p side, okay. By a process which I told you just now, this process is called diffusion. I think till now it's clear. Everybody's clear with this one. Is it okay?
Yes, sir.
Okay.
Yes,
okay.
sir.
Now check. Something more nice will happen, okay. Do you agree, right? When the holes and electrons are crossing, okay, do you agree that there is a chance that they will combine or not? Because a hole always attracts what, guys? Electrons. So what do you think? They just sit like that or they can combine?
They can combine.
They can combine, okay. Now the point is, will they combine everywhere in the n-type and p-type, or they'll only combine near the junction?
Near the junction.
They will combine near the junction, okay. Okay, now don't forget this also. If a hole is going to combine with an electron, guys, okay, it's like this, right? It's like this, say, it's like there's a hole and the electron, okay, is going to go and sit in the hole, right? Now you tell me, okay, if the electron goes and sits in the hole, okay, you tell me, is the electron free or not free anymore?
Not
Not free. Even the hole is there or hole disappears?
Disappear.
Hole also disappears. Hole also is not there, okay. So now you tell me, okay, these charges, right, which have combined near the junction, okay, are they free charges or they are not free charges?
Not free.
Not free.
They are not free charges. They have crossed, but don't forget, they have really crossed, okay. The one side becomes positive, you can see the n side. Okay, let me just rub all of them and let me show you, okay, that all this has become positive. See, the n side has become positive because of diffusion, okay, and the p side has become what? Negative because of diffusion, okay. But don't forget, after this they cannot move anymore, okay, because near the junction they are, and they are going to what? They are going to combine, and they are not free charges, okay. This region, now you tell me again, okay, this region is what, guys? I'll repeating again. This region is near the junction, and near the junction the charges have combined, and in this region, okay, this region which I've marked with blue marker, okay, here, say this region, you tell me, they have free charges or no free charges? No free charges, because they've combined. Here also they don't have free charges, they've combined, okay, they're combined together like that. So my point is this, okay, this region is called depletion layer. If you look at the question, one of your question will be what is depletion layer, okay. So this region is called depletion layer. Can you understand, guys, what is depletion layer? Can you understand this region here, this one which I'm marking? You can check, this region is called depletion layer. And what does this region has? This region has free electrons or not free, no free electrons or free charges?
No free
No
charges.
free charges. And this region is called depletion layer. Depletion in a way is called depleted also. Depleted means to be over, no? Over, okay. Depleted is like over, okay. So yeah, so this region is called depletion layer. Can you understand this, guys? All of you?
So it will cancel out.
It will cancel out. Cancel out means what?
Plus minus.
Yes, of course, because see, the electrons and holes are combining here, no? Okay, so they will cancel out, but don't forget, they have already crossed also. They will have to cross because of diffusion, no? Because concentration is less on the n side for the holes, and concentration is less on the p side for the electrons. So they will really cross, but they will cross, they will combine, but electrons will tend to stay in the p side near the junction, and the holes will try to stay near what, guys? Near the n side. Okay, why it happens? Because you can see this electron will try to pull the electron or will try to pull the hole, guys.
Pull the hole.
That's why the hole will be towards the n side. Okay, it will not leave, it will stay there, but it will be crossing the junction. Can you understand the diagram, or the idea is clear, guys, all of you?
Yes, sir.
Okay, Rishikesh is clear.
Yes, sir.
Nakisa is clear. Nakisa? Rohan?
Yes, sir.
Okay, Dasanba, I don't know. Listening, Dasanba is listening?
Yes, sir.
Okay, fine. Okay, so till now everything is fine. Okay, now let me also tell you what is potential barrier. Okay, so just check, see. Okay, let me go back, let me just draw again, no problem with that. Let me just do this. Okay, Nakisa is also responding. Okay, fine. So see, okay, so we have, okay, negative charges, positive majority charges. This is p type, this is n type. Okay, Abhay also join. Okay, then we have positive charges here, we have negative charges here. Okay, now see, I told you the holes will cross the junction, they will go to the n side, so they'll crowd here near the junction, they'll crowd. Electrons will cross the junction, they will reach the other side, they will also crowd. Okay, they are together now bounded. Okay, they are not free, charges, but the holes will be slightly in the n side, and the, okay, it's not writing, I don't know why. Okay, and the electrons will be slightly on the p side. Okay, what happened? Okay, my Apple Pencil is not writing, I don't know what to do. Wait, okay, now it's working. Okay, see, so this side, yeah, I told you becomes negative, they are not free, as I told you. And this layer, right, it has certain size. Okay, by the way, and you can imagine it's like a wall also. I'll tell you why it's like a wall. See, do you agree with me that this electron, right, what do you think, what is the tendency of this electron is, guys? Does it wants to stay there, or it also wants to go to the p side? What do you think is the tendency of this electron? This electron also wants to go to which side, guys? It is also near the junction. Okay, it also wants to go to p side. Okay, this electron also wants to go towards the p side. This hole also wants to go towards the n side. This hole also wants to go to the n side. Okay, but the problem is this now. See, already we have this negative charges, negative charges, negative charges, negative charges, negative charges, negative charges, negative charges. They are like wall, okay, and they don't like other electrons crossing. They will repel them, okay. Do you agree with that? So look at this, okay. This electron, if it wants to cross, what will happen, guys? It will allow the crossing, or it will try to stop the crossing, guys.
We will try to stop.
It will try to, yes, very good, okay. I think you understood this part, okay. It will try to stop the crossing, okay. Even for this electron, see, this electron also wants to cross, but these electrons which have already crossed, okay, and they are like forming a wall there, okay. So wall, I think you can understand why am I calling it wall. Can I start calling it barrier, guys? Barrier. You know
Yes,
what is
sir.
barrier, right? So it is
Yes,
acting
sir.
like a barrier, okay. All these electrons, they are acting like a barrier to what? To other electrons to undergo diffusion. So you tell me, okay. The same thing happens with holes or not? See, this hole also wants to cross, but already some holes which have already crossed, and they are now crowding the junction, okay. So these holes, okay, these holes, they will not allow these holes to cross. So these holes also, they behave like what, guys? They also behave like wall,
Barrier.
okay, barrier, or let's say wall, okay. So now you tell me, the process of diffusion will continue, or the process of diffusion is going to stop? The process of diffusion is going to stop, okay. Okay, now I think at least till now I think you are fine with this, okay. Now check something, say we can also calculate the diffusion current, as I will show you, but let's try to understand now what can be done, okay. Say instead of looking this whole thing like that, okay, like a positive, 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 or negative, 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 I can just do like this. See, I can imagine as if there is a battery here which has a positive sign here, and I can say that there's a battery here which is what sign, guys? A negative sign, because you know, right, a battery has a positive and a what? And a negative, okay. And this is a real battery, or is not a real battery? What do you think, guys? Is it a real battery?
No, sir.
So it is called fictitious, okay. Fictitious, it is a fictitious battery. It's not a real battery. First of all, that's the idea, okay. And what does this battery do, guys? This battery stops what? Stops diffusion, okay. Diffusion, okay. I think you can understand the charges, how they look like, and that's how they stop diffusion, okay. Now see what can be done, okay. So I can just imagine, check, okay. I can imagine it to be like a positive side, and this one to be negative side of this fictitious battery. And you know what I can do? I can do this, see, guys. Check, okay. Now tell me whether it makes sense or not, okay. See, do you agree that I can come and apply another battery, a real battery from outside, okay, such that, check, okay, the N side I'm connecting it to the negative side, and the P side I'm connecting it to what side, guys? Check. Connecting to the positive side I'm connected to P type, N type I'm connecting it to negative of an external battery, okay. Now you think and tell me, okay, this negative, okay, this negative side of the real battery that I've applied, real battery, okay, what will this negative side of this battery do to these electrons that are already there in the N side, guys? Will it pull it, or it will try to push them, guys? What do you think?
Push.
It will push. It will try to push, okay. This will try to push, this will be pushed, because this is negative, which is connected to negative side, say, okay. So all these electrons, okay, right now you tell me what is their tendency because of this real battery, guys? They want to stay on the N side, or they want to be pushed to the other side?
Push to the P side.
To push to the P side, okay. But let me tell you, see, if, okay, if this battery is around 0. Let's say 1 volt, okay, very, very small. Look at this. Did I apply a really big battery or very small battery? 0.1
Very
volt
small.
only. It's a very, very small battery or voltage that I've applied, okay. This voltage, what do you think, guys? It will be enough to push the electrons, or it may not be enough. What do you think, guys? It may be enough, or it may not, because it's a very small battery we are applying, no. So what can happen, guys? This battery that I've applied, right, may not be enough to what? To push the electrons on the other side. Can you understand this?
Yes, sir.
Yes, sir.
Okay, yes, okay, but you also have to understand this, okay. This 0.1 volt, okay, may be just enough, okay, I'm repeating again, maybe just enough to send only maybe few of them, okay, I'm repeating again. It may not send a very large number of them, because a battery is pushing the electrons, but it may send, right, it may send how many, guys? Very large number of electrons or very few electrons? very
Mm.
few electrons. And why it is happening? Because there is already a negative side, right, on the p side, which will not allow them. Okay, now let's really do this. Okay, see, suppose I do the same thing on the other side, right? The p type is connected to positive side. You can check this is the p side. I'm connecting it to the positive terminal of the battery, the real battery. Even the holes will be pushed. Okay, now you tell me, the 0.1 volts that I've applied, right, will be enough to push many holes or just few holes, guys? Few or very few, actually. Very few holes. Okay, so that is quite all right. Okay, so that has happened. Okay, now let me tell you few more things. See, then you will understand what is going on. Okay, see, now let me do this. See, let me increase the voltage to 0.3 volts. Let me increase to 0.5 volts. Okay, let me increase to 0.7 volts. See, I'll tell you what is happening. Okay, now when I apply 0.3 volts, what do you think, guys? Electrons will be pushed or more electrons will be pushed?
More electrons.
More electrons will be pushed, but still, okay, the numbers will be what? Very few. Okay, then suppose I have reached a value of how many volts, guys? 0.5. Now again more electrons will be pushed and more holes will be pushed from both sides. Okay, and they will cross the junction. Okay, but again the number is what, guys? Very small. But look at this, after you reach a value, okay, a particular value of around how much volts, guys?
0.7.
0.7 volts. It changes with different semiconductors. Okay, but for the time being I'm giving you the best example right now. Okay, but suppose you have applied here, you know how much? 0.1, but let's say 0.7 volts. See what happens now. Okay, this 0.7 volts that you apply, okay, is found to be enough, okay, or let's say just sufficient. Okay, just sufficient to overcome the wall. This is the wall. See, this is the wall. Okay, this is the wall we have. See, this is the wall. This wall is also like a battery, huh? This wall also has certain voltage, and you know what? This 0.7 volts that I told you just now, we are applying over here. This 0.7 is so, okay, not so much, but let's say it is almost good enough to send many of the electrons. Okay, and you know what has happened? The plus has reduced this minus. You can see this is a minus here. The plus, right, will reduce this minus, and this plus will be reduced by this minus that we have, okay, that we have applied. And as a result, you know what, this battery, right, or this battery which is formed by this wall, right, will become smaller and smaller. Can you understand this idea? Okay, let me ask you like this. Can I tell you this plus, what will it do? Tell me this, guys. This plus, what can it do? Do you agree that it can pull the electrons from this wall or not? There's a wall here, if you remember, right? So what can this plus do, guys? This plus, which is here, connected here, see, this one. This is connected to positive. What can this plus do? It will push the electrons or pull the electrons?
It will pull the electrons.
It will pull the electrons. So when it pulls the electrons, what happens to this wall, guys? It remains like this or it becomes smaller?
Becomes smaller.
It becomes smaller. And what will this minus do, guys? It will pull what, guys? It will pull what? Holes. Will it pull holes directly from the other side, or it will start pulling from the wall? What do you think first?
It will start pulling from the wall.
It will start pulling from the wall. So this wall will become bigger or smaller and smaller?
Smaller.
And when I apply how much, guys? Look at this. How much volts?
0.7.
0.7. Automatically you will see this, the wall will start becoming shrinking. Okay, and you know what, lots of electrons and lots of holes, they can cross the junction. Can you understand? So you tell me, okay, how much volt is required to really overcome the wall? How much voltage do you think is really required? 0.1, 0.3 or 0.7?
0.7.
Yeah, this is known as potential barrier. Can you understand? This is known as potential barrier. That was set up here. Okay, this was around 0.7 volts. That's why, you know what, how much we are applying? We are also applying how much? 0.7 volts to overcome this battery that is formed here in the junction. Okay, and that will cause a very quick transfer of charges once we apply 0.7 or let's say more than that. Okay, I think this idea is a little bit clear, right, guys? What is potential barrier? Something is clear at least.
Yes, sir.
Okay, so I'm going to ask you a very quick question. Okay, so what did you learn just now? Tell me. If I take a p type or let's say n type, and if I join with a p type, N-type has majority negative charges, electrons. P-type has majority holes. We also have minority charges in N-type, which are holes, and P-type minority are electrons. What is the first thing I told you happens, guys? The moment we join them, we get a device which we call is what, guys? This device is called as diode. Our full name is PN junction diode.
Junction.
PN diode also you can call it, okay? But let's say PN junction diode, okay? What is the first thing that will start, guys? Tell me. The first thing that will start is what? Because of concentration difference on both sides. Okay, yeah, what will happen? Electrons will, from which side? Electrons from N side, they will go to which side, guys?
P side.
P side, okay, because they are pulled by the, okay, concentration difference. And holes will reach which side, guys? N side. Now, will they just cross, or they will cross and combine also?
Cross and combine.
Cross and combine. So now you tell me, this region here, right, near the junction where they have combined after diffusion, okay, this region has free charges or no free charges?
No free charge.
No free charges. And this region has a name. What is
No
this
free
called?
charge.
Yeah, what is this called, guys?
Depletion layer.
Depletion layer. Yes, okay, you have understood this
Depletion
one.
layer.
Very good. Okay, now also tell me one more thing. Does it have a size? Yes, it has size. Okay, it may be very big wall. If it is a very big wall, it is going to have a lot of potential barrier. Okay, so check now. I also told you, you can imagine as if this side has become what, guys? Positive or negative?
Positive.
Positive, yes. And P side has become slightly what?
Negative.
Negative. Okay, and what does this do, guys? This potential,
Negative.
yeah, this potential helps further diffusion, or it will stop the diffusion, guys?
Stop the diffusion.
Okay, yes,
It will
stop the
stop the
diffusion.
diffusion.
Yes, okay, and it acts like as a battery, right, which is stopping the diffusion, okay, stopping the movement of charges. And this has certain value also, right? In our case, I told you how much is the value? 0.7
0.7.
volts. Okay, it's like a wall which is like a battery, and this battery has how many volts? 0.7 volts. Okay, and this is what I told you is known as potential barrier. Okay, now why did I call it potential barrier? Is because now I can come back and apply a real battery such that I take the N type connected, okay, to the negative terminal of the real battery, P type connected to the positive terminal of the real battery, and you know what will happen now? You tell me. From the N side, who will try to go to the P side? From the N side,
Negative.
electrons or holes?
Electrons.
Yeah, so they will go or not, guys? What do you think? Will they go for any value, or smaller value also will they go? For smaller value also they will go. But will they go? Very large number will be transferred, or very few of them will be transferred?
Very few.
Very few, because the wall is still there. Okay, the wall is still there intact. Okay, but if I reach a value called how many volts, guys? Around 0.7 volts. Now it has become so much positive. Okay, this has become so much positive, and this side has become so much negative, that the electrons now get so much energy to overcome this battery which was created by this diffusion. Okay, so now we are overcoming which volts, guys? We are overcoming how many volts? We are overcoming 0.7 volts, or let's say, yeah, we are overcoming the potential barrier. Now the process of transfer of charge from both sides, okay, the holes and the electrons, will be very easy. Now you tell me, are we going to get current or no current? Now we start getting very large current. Okay, so that is what this is all about. Okay, guys, when I send you the notes, okay, please read. I told you the question will be what is depletion layer. Okay, then I told you what what will be depletion layer, what is potential barrier. Please read it. For germanium, it is around 0.3 volts for germanium. Okay, we have to overcome 0.3 for germanium and 0.7 for silicon. Okay, so these are just random value, not random but approximate values. Cannot say these are very, very exact. Okay, now comes the most important thing. So what is the logic behind of what is going on? Say now this is the most important thing. If you have understood this, our job is done, almost done. Okay, this chapter is almost done. See, this is p-type semiconductor. By the way, in your school you have finished, guys, this topic?
Yes, sir.
Yes, sir.
Okay, you finished this. Okay, all of you? Okay, good. Okay, see, so we have p-type and type.
Yes, sir.
Okay, so I've just changed. Okay, p-type and type, I'm just writing left and right. Okay, so no problem with that. Let's be clear with the same thing. We have positively charged, majority charge carriers, holes, minority charge, majority electrons on the other side, minority electrons, minority holes here. Okay, so you know this picture already. I told you we will form a depletion layer. Okay, this p side will become negative. I told you that, which you have learned. N side will become positive, which you have learned again. Okay, this becomes like negatively a charged portion, okay, and this one becomes like a positively charged portion, okay. So this is positive, negative. I told you this barrier is around 0.3 volts, or let's say this is around 0.7 volts, okay. We have to overcome this barrier, and that's how we can start transferring the charges, okay. Now check, I need two of these diagrams, okay. I'll tell you what's the next topic also, okay. Oops. Paste, see. One second, okay. Oh, no. Oh, string, yes. अच्छा हाँ अच्छा मैं अच्छा guys give me just 1 minute, okay, 1 minute, I'll come back. Okay, so sorry, see, okay, check now, okay, these two things I will need, and this is the most important part. Now see, what is your topic? I'll tell you. Your topic will be like this, okay. They will ask you what is forward biasing, okay, and then they will ask you what is reverse biasing, okay. Check, okay. It's very simple thing. See, if I take, okay, check, if I take PN junction diode, okay, both of them are there, see, and I take the P side, check, okay, and I connect it to the positive terminal of an external battery, positive terminal, see, the P side, okay, the P type, see, P type is connected to positive terminal of external battery, and the N side is connected to what, guys? Negative terminal of the external battery, okay. Then this connection, right, this connection, the way we have connected, right, okay, this connection is known as what, guys? Forward biasing, okay. I think this part is clear, okay. Same thing we'll do here. We'll take the P type and we'll take what? We'll take the N type, but this time we'll just do the opposite, guys. So P type, now you tell me, what will I connect it to? Negative or positive?
Negative.
Yes, okay. And the N type, right, I'll connect it to what? Positive, yes. Then this connection, right, we were going to call it what biasing, guys? Reverse biasing. At least you are clear, right, which one is connected to what, right, guys? Check. Yes or no?
Yes, sir.
Okay, now I'm going to ask you a question, okay, very simple question, okay. Look at the diagram and tell me, okay, in the first one, this one, okay, this one, these are all majority charges I'm marking, okay. They are more in numbers, the holes are more in numbers, okay. Here electrons are more in number, okay. Now look at the diagram and tell me, okay, from the P side, because from the P type, okay, because I've connected the external battery positive to the P side and negative to the N side, from the P side you tell me, holes will cross or not cross? Who will cross? Holes will cross or not? Yes, who will cross? Holes will cross, okay. So let's be clear, from the P type, right, who will cross the junction, guys? Is it the holes or the electron? Holes, okay. And do you agree with me, the holes are what? Any charges or they are majority charges? Who are crossing? Majority charges are crossing, huh? And let's check from N side. From N side, tell me who's crossing? Electrons or holes? Electrons will cross because the negative applied, right? Check, the negative applied will push the electrons. They will go and cross the junction from the n type, right? Who will cross this junction, this wall? Electrons or free electrons. And what do you think, guys? On this side, are the electrons any charges or they are majority charges?
They are majority charges.
They are majority charges. Okay, now you think and tell me. Okay, look at this minority charges on both sides. This is a minority charge, minority charge, minority charge, minority charge on both sides. Okay, will they cross or they'll not cross? Think.
They won't cross.
They won't cross because the plus, what do you think, will push the electrons or pull the electrons?
Attract.
It will attract. So they will not cross the junction. They will not go there. Okay, they will not cross the junction. So minority charges will not cross. Even these are minority charges on this side. No, will they cross or they will not cross, guys? They will not cross. They will be pulled in this direction. They will not be crossing. Okay, so you think and tell me. Okay, in this forward biasing, right? I'm repeating again. In forward biasing, right, when you connect the p side to positive and n side to negative, which charges from both sides are going to cross the junction, guys? Majority charges or minority charges?
Majority.
Majority. Yes or no? All of you clear with this one?
Yes, sir.
Yes,
All
sir.
of you. All of you.
Yes, sir.
All of you. Are. Some of you have stopped replying. Yes. Come on. Guys, don't be lazy. So,
No,
Yes,
sir.
sir.
not clear. You're saying not clear, no? Shristi?
No. Yes, sir.
Not clear. Say, okay. Look at this. What did I connect here? What is this?
Positive.
Positive. Okay. Positive is connected to which type?
P type.
P type. So what will this positive do? It will pull the holes or push the holes?
Push the holes.
Push the holes, and when it pushes the holes, right, will they cross the junction or not?
Yes, sir.
So who is crossing the junction? Tell me. From P side.
Holes.
Holes. They are majority, right? Many of them, right? Majority means many of them. Many of the holes are going to cross. Okay. And what about N type? N type is connected to which one? It's connected to
Negative.
negative. So negative will pull or push again this electrons.
Push.
Push. So electrons will also cross. So when the electrons and the holes, they cross from both sides, are they both, do you agree, from on the both sides, on the P type and N side, they are both majority charges or not, which are crossing?
Yes, sir.
Okay. And minority charges, they will cross or they will not cross? I'm talking about
They will
crossing this junction. They will not
Cross.
Okay. So till here I think everybody got me now. Okay. So now check, why am I speaking like that and what is the advantage of whatever I am saying? Okay. So look at this. Okay. See. Check. Okay. When the holes, okay, in this diagram, tell me, holes, do you agree they are moving to the right or not? Check, all of you.
Yes, sir.
Okay, I'm going to write here. Okay, holes are moving where, guys? To the right. Holes are positive charges. So current due to holes will be in which direction? To the right. Yes or no? All of you.
Yes, sir.
Because when the charges move to the right, the positive charges, the current also goes to the right. Okay. And do I get the whole current or not? Yes, we get whole current because holes are positive charges. They are moving. They have to move. Okay, to give you current. No, charges have to move. What about electrons? Where are electrons moving, guys? To the left or right?
Left.
To the left, from N to P. Okay, and holes are moving from P to N. Electrons are moving from N to P. Okay, and very large number of them. So you tell me, where is the electron current, guys? To the left or the right?
Right.
To the right. Whole current is also to the right, and electron current is also to the right. Okay, as a result, the total current I'll get is what? IH plus
IE.
IE. That's the total current in this semiconductor. Okay, right now. Okay, and you tell me, what kind of current will I get? Large current or small current?
Large.
Why large current? You tell me now. Because from both sides, majority charges are crossing or minority charges are crossing?
Majority charges.
Majority charges are crossing, and that's why. Okay, what kind of current we'll get, guys?
Large current.
Large
Large
current.
current.
Okay, and what does it indirectly means? You know, indirectly it means this wall. What do you think? It's a wall, right? It's a barrier. Is this barrier offering resistance or less resistance? What do you think, guys?
Less
Less
resistance.
resistance.
Less resistance. So always remember, what kind of resistance do they face? Less resistance. Okay, so please remember this. Whenever I connect the P type to positive, N type to negative terminal, right, automatically we'll see most of the charges are crossing, and the wall, okay, is going to behave like as if it has failed. Okay, and the resistance or the size of this wall also will be lowered. I can show you another way. See, this plus is connected to what? Minus of this wall, and this minus is connected to what, guys? The plus of the wall. So what do you think? It will help the wall or it will reduce the wall, guys?
It will reduce.
It will reduce the wall.
the
It is because same like the wall or it is opposite to the wall, guys. The battery I have applied. The applied battery is same sign with the wall or the opposite to the wall, guys.
Opposite.
That's why the wall is going to reduce in size. That means you tell me the depletion layer will have same size or reduced size?
Reduced size.
Reduced size. Please remember this. In forward biasing I told you so many things. When I revise I think it will be clear. Okay, let's go to reverse biasing very quickly. I think you will understand now. Okay, very nicely. Say, so when I take your this second case which I told you is reverse biasing. Now you think and tell me. Okay, the negative terminal of the external battery is connected to P side. So now you tell me who will be pushed from the negative terminal of our battery? Who will it push? The holes or the electrons from the P side? The negative terminal, who will it push? Will it push the electrons or the holes?
Holes.
Holes again. Will it push the holes like that?
Electrons.
When I say push, no, push across this junction. So yeah, who is going to cross, guys? Now electrons, right? From the P side electrons will cross now, and from the N side, guys, who will cross? Look at this. This is plus connected to N side. Who will cross now? The holes or electrons? Holes, right? Okay, now you tell me, are these charges really crossing? Yes, they are crossing, no problem with that. But these charges on both sides, this one and this one, what do you think? Is majority or minority charges?
Minority charges.
Minority charges. And this also, right? It is majority or minority charges? Minority charges. So now you tell me, okay, the charges are moving? Yes, they are moving. But which charges are moving? Majority or minority? Minority. So whenever you apply, so listen to me. Whenever you apply, which kind of connection, guys? Reverse biasing. From the P side and from the N side, okay? Charges will cross the junction, yes, but it will be all the charges or only the minority charges? Only the minority charges. Now you think and tell me the current, okay, in this case, current, okay? What do you think? It's going to be large or small? Small current, okay? I think you're clear with this. Okay, Srishti is clear with this one. Just check.
Yes, sir.
Okay, so now the current will be very, very small, okay? Indirectly, what will I say now? The resistance offered by this wall, what do you think I'm going to say? It's going to be large or small? Large. Now the resistance is going to appear as if it is what, guys? Large. Very, very large, okay? Can you understand why I'm saying large? I can show you one more thing. Say, do you agree that now the minus sign, okay? Look at this minus sign. This minus sign is of the barrier. This is the plus sign of the barrier. Now the minus sign is with the minus sign. The plus sign is with the plus sign. What do you think it will do to the barrier, guys? It will help the barrier or oppose the barrier, guys? What do you think?
Help the barrier.
It will help the barrier. It will build up the minus sign here, and it will build up what sign, guys, here? The plus sign there. Okay, so now you tell me the depletion layer will be same size or larger size?
Larger size.
Larger size, because of which the wall has become large, and that's why I told you, right, the resistance also is going to become large. Okay, so guys, can I say, did you really understood what is reverse biasing? But I have to show you the direction of current also. But are you clear, guys? What is reverse biasing? Yes, Rishikesh is fine.
Yes, sir.
Okay, Jonavar is fine. Okay, let's proceed. Okay, see now. Yeah, look at the signs of your direction of your current. Okay, check. In this case, the electrons, these electrons, right, they are going to the right from P towards N. So if electrons are going to the right, tell me what is the direction of current due to electrons? It will be towards the left. Okay, so electrons are giving you current to the left. Where are the holes going, guys? These holes to the right or left? Right or left?
Oh, left.
Electrons are going to the holes are going to the left. If holes are going to the left, what is the direction of current due to holes, guys?
Right.
Left.
Holes are positive, no? Okay, so what is the total current, guys? Will I add them or subtract them?
Add.
Add, because both the
Add.
current due to electrons and holes are in same their direction is opposite, but the current is in same direction. So again we are getting current due to what, guys? Both electrons and holes. But this current, as I told you, right, will be large or small current?
Small.
Small current. And you know the reason, because most of them, many of them, or minority charges will only cross. Only minority charges will cross. Okay, till now, yeah. So till now everybody's clear, guys, all of you? Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So reverse biasing, forward biasing, at least something is clear.
Yes, sir.
Now,
sir.
what question they will ask you? See, they'll ask you this: what is forward biasing of a PN junction? Okay, I have a note on this. I'll send you today only. Read exactly the way I have given. Few changes have to be made. I will tell you what to do in your notes. Okay, and this question they will ask you. See, they will ask you this question. Okay, they'll ask you. Let me write the question. Okay, draw a circuit diagram. I will teach you this today only, then we'll stop for today. Okay, see, draw a circuit diagram to study IV characteristics. Okay, IV characteristics of a PN junction diode forward. Okay, look at this. Okay, study forward. You don't have to call it IV, just call it forward characteristics. Don't worry, you should be fine with the questions. Okay, check. For PN junction diode, number A will be your, okay, not number A, this is number A itself. Okay, this is number A. Okay, also they'll ask you also draw the characteristics. Okay, don't worry, this is very easy. You have already learned actually what is this. Okay, say, check. How will I represent it? Okay, say, by the way, I did not show you, but now I'm going to show you. Okay, see, this is P type, this is N type. I have already shown you, but in symbol, right, this is what you're going to do. See, you draw a triangle, draw one line like this. Okay, this also represents the same device. Say, because in electronics, right, we have the different symbols. No, this is a symbol for a battery, this is a symbol for resistance, this is a symbol for a capacitor, this is a symbol for an inductor, right? So what is this symbol, guys, for? This is a symbol for PN junction diode. Okay, so PN, this line means N type, this triangle means a P type. Okay, so check now. See, so first question is this: draw a circuit diagram to study forward characteristics. Okay, I will help you out with that now. See, I'm going to draw a circuit diagram. I'll tell you what is forward characteristics. Okay, check. So I will draw this triangle here. I'll draw this N type. I'll draw the two ends of it. Okay, don't take more than that. Okay, then you know what, this is obviously, I know this is P type, this is N type. Since they are talking about forward characteristics, right, so you tell me, how will I connect this P type, guys? Should I connect it to the positive of the battery or negative of the battery?
Negative of the battery.
Yeah, Rishikesh, forward
Positive.
positive of the battery, and this N type will be connected to negative of the battery. Is it clear, guys? This is the same diagram like before. Say, it's the same diagram like this one, but shortcut, no, now in terms of symbols. Okay, so is it okay, guys? Just check. P type connected to positive, N type connected to negative. Now you know what, you're coming to come and give an arrow. I'll tell you why. This arrow means, will you keep the battery fixed or you will change the values? You will change the value of the battery that you're applying. Okay, maybe you apply 0.1 volt, 0.2, 0.3, like that we are going to change it. Okay, till now it's clear, no, guys, all of you? Yes or no?
Yes, sir.
Okay, and
Yes,
what
sir.
do you think, if I change this battery, will the current pass or not? Yes, if you remember, the direction of current will be from where to where, guys? From P towards N. In forward direction it is going to be from P towards N. That's the direction of current. Okay, even the electron current will be in this direction, even the whole current will be in this direction in forward biasing. Okay, so that's the direction of current. So this is, I'm showing you current. Okay, and you know what, we are going to measure these two things now. See, we will measure how much voltage the junction is getting. So we will have to connect a device called what, guys? Voltmeter. This is, I have to connect the plus and the minus, I have to connect it like this. I will also have to measure the current that is passing from it. Okay, check. So I'm going to connect here ammeter. Okay, I have to be more clear with the ammeter. Let me just show you. It is milliampere ammeter. Okay, milli means how much, guys? 10 to the power minus 3 amps of ampere we are going to put. Okay, to measure milliamperes of current. Okay, say, so what I've done, you know what, I have connected an ammeter. Can you see? So tell me, what will it do, guys? It will measure me the current or not? It's an ammeter, no?
Yes, sir.
So this ammeter will help me to measure the value of the current. Okay. And what is this, guys? This is a ammeter or voltmeter? Yes, sir.
Voltmeter.
Voltmeter. What will this voltmeter do? Help us to calculate what, guys? Potential difference across whom? Across the
PM.
across the PN junction.
PN
Okay,
junction.
across the diode. Okay, so you must be thinking, right? Okay, why we are doing that? Okay, let me tell you. See, you will agree with me that if I change the voltage here, if I increase the battery, do you think the PN junction diode will get same voltage or more and more voltage? If I increase the battery here, no? Then what kind of voltage the PN junction will get, guys? Same voltage or more and more voltage?
High.
Higher and higher voltage.
High voltage.
And automatically this current, okay, which I call it forward current, let's call it IF, okay, because it's in this direction, no, we can call it forward current. Okay, now you think and tell me, this forward current, what do you think, guys? Will it increase or not?
Yes, sir.
Okay, so look at my point. My point is this: for how much value of voltage, how much will be the forward current? Okay, how much will be the value of the voltage that you apply, and how much will be the value of current? This change of current with the applied voltage, okay, is known as forward characteristics, and that's a graph that we are going to draw now. Without measuring the voltage and without measuring the current, we cannot draw the graph. This characteristics means what, guys? This characteristics means nothing but graph, and you have drawn this in your Ohm's law. Ohm's law was very simple. Okay, check. Oh, it's not writing again. Oops. 1 second. Oops. Okay, check. See, how am I representing? Okay, when I say forward characteristics, okay, forward characteristics, it simply means how much forward voltage you apply, okay, which can be measured using this voltmeter, and how much current will be passed through this diode. That is the meaning of this characteristics. Can you understand? Characteristics means like a character of this diode, no? How much voltage will give you how much current will pass through this diode, right? So that's the characteristics of this diode. Okay, that is what we are going to draw now in this graph. Okay, and now you tell me. Okay, check. So what is the meaning of this point here, guys? Think and tell me. It is voltage or applied 0 volts?
0 volt.
0 volts. That means, did you apply any battery or apply 0 volts of battery or no battery?
No battery.
No battery. Now all of you think, guys, will those charges, the majority charges, no, in forward biasing, will they cross or they'll not cross the junction, guys? There's a wall
They
there,
won't
right?
cross.
There's a wall there. So will the charges cross or not cross, guys, from both sides?
They won't cross.
They won't cross because you're not applying any battery here, right? So they will not cross. Okay, so if they are not crossing, what kind of current do you think I'm going to get, guys? How much current will I record here?
0 current.
0 current. Is it clear, guys, all of you?
Yes, sir.
Yes, sir.
Okay, this is clear. Okay, fine. So our starting is from which point, guys? When the voltage is 0, current is also 0. Okay, right? Till now it's okay, no?
Yes, sir.
Okay, now check. Let's increase the voltage. Okay, we will do like this. See, as I told you, right, there's an arrow here. We'll increase the voltage and we'll measure from this voltmeter. We will increase, let it increase to 0.1 volts, let it increase to 0.2 volts, keep on going till you go to 0.7 volts. Okay, let me go to 0.7 directly. See, 0.7 volts. Okay, now you think and tell me, till I reach 0.7 volts. Okay, till I apply 0.7 volts, means less than that, suppose. Okay, what do you think? Will lots of charges will cross or less charges will cross?
Lots of charges will cross.
Till we reach 0.7. Before reaching
Less
0.7.
charges.
I showed you earlier, right? Because if I apply here, right, 0.1 volts, what do you think? It's a very huge voltage or very small voltage, guys? I told you, no? It's a very small voltage which cannot overcome this wall that we have. Remember, there's a wall here, no? Which is not allowing the charges to move. So 0.1 volts, what do you think? It's a voltage or very small voltage?
Very small voltage.
So it will allow a lot of charges to cross or very few charges to cross?
Very few charges to cross.
Okay, so now you tell me, what kind of current do you think I'm going to record here, guys? A very large current or very, very small current?
Very, very small.
So look at this, look at my graph. The graph is going to rise, but it's not going to rise very quickly till 0.7. But The moment I reach 0.7 volt and I cross 0.7, I keep on increasing 0.8 volts, 0.9 volts, 1 volt, 1.1 volt, so on. Okay, if I keep on increasing now, you think and tell me now what will happen. Now the current will be same, or now the current will start increasing rapidly, guys.
Increase.
Now the current, now the current rises rapidly. Why? Because we have applied 0.7 volts, which is just enough to overcome this barrier. Okay, this wall you can easily jump now. It's like a wall. Now you can easily jump. Okay, with how much volts? 0.7 volts. Okay, easily you can jump this wall now. These electrons or charges, they can easily jump now. So now you think and tell me what kind of graph we get now. Rising slowly or very fast now, guys?
Very fast.
Very fast. What does it indicate? It indicates the current is rising or rising much faster now, guys.
Current is directly proportional.
No, not
Voltage.
let's not say directly proportional. Okay, that's not the thing to say. But let's say right now the current is going to rise or rise rapidly now, Rishikesh.
Rises rapidly.
Okay, does it happen before the stopping potential or after the stopping potential?
After the stopping
Okay,
potential.
that was acting like a stopping potential. Okay, we have a different name now. Okay, this voltage, okay, we have a name now. We call it knee voltage. Okay, because what happens after this voltage, guys? After this voltage in the forward direction, right, the forward voltage, the current is found to rise very, very fast. Okay, not like before. Okay, the current was almost zero before. Okay, but now the current is going to rise very, very fast. Okay, and it looks like a knee. Okay, your knee looks like this, right? Check my diagram of your legs. This is like your knee, no? So this is like the knee. See, that's why. Okay, it's called what voltage, guys? The graph looks like a knee. Okay, that's why it's called a knee voltage right now. This value is called knee voltage. Okay, so can you understand, guys, at least what is knee voltage?
Yes, sir.
So what is knee voltage, guys? Tell me, is it a reverse voltage or forward voltage? First of all,
Forward voltage.
forward voltage, after which what happens? The current through the junction rises or rises very fast?
Rises rapidly.
Rises rapidly. Okay, and that is what is known as knee voltage. Okay, so every time you have a diode, okay, you will notice that if I supply little bit of voltage, the current will not rise rapidly, but after crossing a certain voltage called knee voltage, the current is going to rise very, very rapidly. Okay, so I hope you are clear with this, what is forward voltage and what is this called now, guys? This whole graph is called what characteristics, guys? Forward characteristics. That means how much current will I get when I apply how much voltage to this junction diode. Okay, and don't forget what is the value of the current that I'm going to get, guys, in what range it is. Milliamperes means 10 to the power minus 3 amperes. Okay, so that is what we are going to get, guys. Can I say it is clear?
Yes, sir.
Okay, so what is your question,
Yes,
guys?
sir.
Please read the question. The question is draw the circuit diagram. That means it comes. Okay, boss, I'm telling you, so you have to draw this circuit diagram. In my notes I have not drawn two things. I have not drawn the voltmeter and I have not drawn the ammeter. Okay, so you have to draw these in your diagram. Okay, if you have confusion you can ask me. Okay, I'll send you the notes, you please rectify that. Okay, let's go to the next part. See, same question will be asked, but this time you know what will happen. Same question, but this time will be asked for what question? What, guys? For reverse biasing. Let me finish this today only. Okay, then next day we will have very easy time. Okay, see. Okay, check. I'm again going to draw the PN junction diode. This is how I told you we have to draw it. This is the P type, this is the N type, and you know, right, this time how we are going to join, guys? I'll join the P to what, guys? Negative, and the N I'll join to positive. Is it okay, guys? Just check. Is it reverse biasing? Please calculate.
Yes,
sir.
Reverse biasing done. Okay, but what is our job? Again, we have to find the graph, right? How much current will I get? How much reverse current this time will I get? And reverse current will be in this direction, right? From where to where, guys? N to P or P to N?
N to P.
N to P. This is a reverse current. Okay, and what is this voltage, guys, called? We call it voltage or reverse voltage?
Reverse voltage.
And there should be an arrow here because we are going to keep on changing it, right? Okay, and I also need to record this current, right? So what am I going to put here, guys? How to record or measure this current? By putting a ammeter. Voltmeter. Rishikesh? Ammeter. Okay, okay, but let me be clear this time. Will I use milliamperes or microamperes this time? I think you can understand which one to use. Micro. 10 to power minus 6. Okay, microamperes. Why? Because what kind of current am I getting now, guys?
Very, very small.
Reverse current. Reverse current is due to majority charges or minority charges?
Minority.
So it's going to be very, very small, of the order of 10 to the power minus 6 amperes. Okay, I think we are clear with this one. Is it okay, all of you guys? Check, check, check.
Yes,
Yes,
sir.
sir.
But I will also have to use a voltmeter, so let me draw it here. Okay, I'm going to connect it across your junction diodes. I'm going to put it here. This is your voltmeter. The plus and the minus, check the sign. Okay, this is how you have to put the plus and the minus. Okay, so now check. See, once I do this, the voltmeter will tell me the voltage across this, and how much voltage is appearing here will depend on how much voltage we apply here. If we apply more voltage will appear there. Okay, so now check. See, try to understand now our graph. Okay, our graph this time will be drawn like this. See, earlier we have used this one, forward voltage, forward current, VF and IF. In this direction I'll call it what, guys? Reverse voltage, and in this direction I'll call it what, guys? Reverse current. Can you understand? Now I'm going to use this side and this side, the third quadrant. This one
Yes,
already
sir.
used for forward. Now this is for reverse. Automatically I think you can make out. Okay, you cannot, you should not draw here. Okay, no chance, please do not draw there. Okay, so now tell me, this is a graph between what and what, guys?
Reverse by
Reverse voltage and reverse
current.
current. What is the order of reverse current? Let me write it here. Micro amperes. Okay, now again let's start with our basics. Okay, what is the meaning of this point, guys? How many voltage we have applied?
0.
0 volts. What do you expect again, guys? At 0 volts, how much current will pass?
0 current.
0 current. No current will pass. So our graph will start from this 0 comma 0. 0 voltage, 0 reverse current through the diode. Okay, but let's do this now. Let's increase this voltage. Okay, let's increase this 0.1 volt, 0.2 volts, 1 volt, 2 volt. Okay, let me just increase. Okay, keep on increasing. By the way, don't forget what kind of resistance I'm going to get, guys, in reverse biasing. High or low?
Very large.
Large resistance, right? Large resistance. I'm going to get large resistance. So you tell me, even if I apply 1 volt, 2 volt, 3 volt, okay, 1 volt, 2 volt, and let's say 3 volt, right? What kind of current do you expect to get, guys? Large current or small current?
Very small current.
Two reason why small current, right? Because the resistance is very, very
Large.
and the charges which are crossing are minority or majority charges.
Minority
So
charge.
that's why
Minority
that's why the current is going to be very, very low. See, the graph is not rising. If rising means to go down here. Okay, so the graph is rising or not rising very fast? Not rising very, very fast. But look at this. Okay, if I reach, we have a very nice voltage now. Okay, suppose now, okay, look at this, I reach a voltage around 11 volts, still I get less current. Okay, but suppose I reach 11.9, still less current. Okay, 11.9. I'm repeating again, I've reached how much, guys? 11.9. Let me just rub all of them. Let me say till 11.9 volts. What kind of current I'm getting? Very small current. Okay, because the resistance is very large. But exactly at 12 volts, look what will happen now. Okay, now the voltage becomes so high that this will happen. Check. Okay, let me go back here. Okay, this is a reverse biasing diagram. Yes. Okay, I have applied how many volts just now? I told you guys 12 volts. Just an example, it can be different for different semiconductors. Okay, but check, I have applied 12 volts, and you know what will happen now? Just check. Okay, look at the diagram. Now this 12 volts means what, guys? This is negative or very much negative this side? 12 volts is a large voltage, no? It's a large battery. So this will be negative or very much negative, the battery side. This will be very much negative. And this will be positive or small positive or very big positive. Positive, and this side will be negative. Now 12 volts, okay, listen to me very nicely. Okay, then I'll stop. Okay, check. This 12 volts becomes so large that even these holes which are in the junction, okay, they start crossing. Can you understand? Now the barrier will break again, and the minus, look at this minus. Okay, this minus, right, they will be pulled, okay, in this side. Can you understand what is happening at 12 volts?
Yes, sir.
So what is happening at 12 volts? Tell me, guys. The bonds in this barrier, they are still intact, or they start breaking?
They starts breaking.
They start breaking. Can you understand, guys, what I said just now?
Yes, sir.
So when the bonds in the junction, right, they start breaking. Did they break for 11.9 volts? No, for in this example they did not break, okay, but 12 volts was such a big voltage, no, they started breaking the bonds here. So now you tell me, when you break the bonds, what kind of charges will you get here? Bound charges or free charges? Now
Free charges.
free charges. Now you tell me, those free charges will just sit there or they can cross? Now
They can cross.
they can cross, and automatically will you get current or very large reverse current now, guys?
Very large.
So you will start getting a very large reverse current, okay. The graph is going to go down very nicely like that. See, very much rapid increase in the reverse current, okay. This voltage, okay, which we have reached, and after which the breaking of bonds have started taking place, right? I told you this example was how many volt, guys? 12 volts, no? After which the current rises rapidly, right? This voltage has a name, we call it Vz. This is called Zener voltage. Please remember this. Zener voltage, or another name is breakdown voltage. Can you understand what is breakdown voltage, guys?
Yes, sir.
Okay, so please tell me, what is Zener voltage? First of all, tell me, it is a reverse voltage or it is a value of forward voltage?
It is the
Ha.
reverse voltage.
Zener voltage is a value of what voltage, guys? All of you, yes, please, guys, we need to stop also. So
Reverse.
respond, yes. Zener voltage is a reverse voltage. What happens when we reach this voltage, guys? Tell me. The bonds,
Current rises rapidly.
current rises rapidly, but why does it rises rapidly? Because
Bond.
bonds in which junction? A depletion layer, right? The bonds in the depletion layer, they are still intact or they start breaking?
Breaking.
They start breaking, and what happens after that? The charges, they become
Free.
and now will you get current or very large reverse current now?
Very large.
Very large reverse current. So this is the characteristics, right? This is the behavior of your PN junction diode. Every time this is going to happen, okay, and this is how it behaves. That's why this is called characteristics or reverse characteristics now.
Reverse
Reverse characteristics. Can I say, all of you, did you understand, guys?
Yes, sir.
Okay, and there's
Yes.
one problem, there's one problem. Because of this reverse current, if I keep on allowing this current to pass, I'll tell you what will happen. The device will become very, very hot. I'm repeating again. What will happen, guys? The device will become very, very hot. Two reasons why it will become hot. Because what kind of resistance we have, guys, in reverse biasing? High or low?
High.
High. In reverse biasing, the resistance is very, very high, and if this large current keeps on passing from a high resistance, if large current keeps on passing, okay, large current is passing, okay, of high resistance, right, from high resistance, right, then the device is surely going to become what, guys? Very, very hot. So that's why, you know what, normally when we talk about reverse biasing, okay, we want to avoid this region. So tell me, do you want to apply more than Zener voltage or you want to apply less than Zener voltage?
Less than 0 voltage.
Otherwise, what will happen?
It will blast.
It will not blast, but it will get damaged, okay? It will become damaged. The whole device is going to get damaged. Can you understand, guys, why I said that? Because if I cross this voltage, automatically the current will be what, guys? Very, very high. And when the current is high and the resistance is also high, the temperature, right, okay, the temperature is going to rise, okay. So basically we try to avoid this region, okay. That's why it has a name, no? We call it what region, guys? We call it what voltage? Breakdown voltage, okay. So I think you are clear with this, but let me just quickly tell you what is the question. Say, what will they ask you, guys, today? What we did? Tell me quickly. Number one topic, what is the question?
What is PN junction?
What is PN junction diode? That's the first thing. Yes, very good. Please study this. I'll send you the notes today only. What is the next question, guys?
What is depletion layer?
Very good. Depletion. Please respond, guys. We are stopping right now.
What is potential barrier?
What is potential barrier? Only he is responding. Potential barrier.
Draw a circuit.
I speak others
Diagram.
also. Then
Yes,
what
sir.
is the? Yes. Next one. What is the next thing we did?
Reverse by.
First we did forward
Forward
biasing. Yes. Second we did
Reverse by.
reverse biasing. In which biasing majority charges they cross?
Forward bias.
Forward. In which biasing we have less resistance?
Forward.
In which biasing we have small size of the depletion layer?
Forward.
Forward, yes. In which biasing we have bigger size of depletion layer?
Reverse.
Reverse, very good. Okay. Yes, nice. Okay. Then they will ask you to draw what? circuit
Circuit diagram.
diagram. That circuit
For
diagram will
the-
have to help us to draw a graph, right? And this graph is called what graph, guys? Forward.
Forward characteristic.
The graph is called characteristic. The graph is called forward characteristic. This one, and this one obviously just now what we have done is called
Reverse
reverse
characteristic.
characteristics. Yes, and both the characteristics I have shown you just now. Okay, look at this. This is forward voltage, forward current. If you don't write the milliamperes here, you will get half mark less. If you don't draw exactly like this, see, like this rising, marking a voltage. What is this voltage called, guys?
Knee voltage.
Knee voltage. Yes, if you don't mark this, you will not get good marks. Okay, then on the reverse side, I can draw in the same diagram. What is this voltage called? Reverse voltage. What is this current called? Reverse current. What is the order of this? Microamperes. And how should I draw it? I should draw it very little, right, at the beginning, but after reaching a voltage called what voltage?
Fuel.
Zener voltage or
Zener
breakdown
voltage.
voltage. Yes, the current will rise rapidly. Yes or no?
Yes, sir.
Yes. Okay, so this is what you need to do. Okay, your exam. Okay, I'm sure they might just ask you something from here. 100% sure. Okay. Okay. Yeah. Also, one more thing. When you draw the circuit diagram, how will you draw? You will draw a battery here. Positive.
Ammeter and a galvanometer.
Galvanometer.
So,
What is he
Voltmeter.
saying? Ammeter, milliamperes,
Ammeter.
and you have to connect here. What, guys?
Voltmeter.
Voltmeter. Yes. Okay. So please read this. I'll send you the notes right now. Okay. So okay. Bye bye. Thank you. We will meet Friday. Huh?
Sir.
bye,
Yes,
sir.
Bye bye.
Sir.
Bye,
Yes.
sir.
Yes.
But thank you, sir.
Somebody saying sir. Yes.
Sir, you said that you will tell the important the derivations,
Oh yeah. Important derivation from which topic, Ryan?
the magnetism, then electromagnetic induction and